Hi, here in this video, we would like to talk about the term surface energy, based on which even we can find another way of defining surface tension. Let's proceed and see what do you mean by that. Let's imagine a metal wire of this rectangular shape. These three sides, we call it like A, B, C, are fixed. On this fourth side, let me arrange a movable wire. It's not fixed, this is movable. So this is difference. Be careful, right? This is not fixed, this is movable. Is arranged like this. Now, let's immerse this frame into a soap solution where the three sides are fixed and the fourth side is free to move. If somebody pulls it, it moves. Now, let's apply by putting it in a soap film. Let's put it in a soap film. So imagine what all I'm drawing is a soap film. So this soap film is a liquid. This liquid has a property called surface tension, as we have already explained many times. Because of this surface tension property, this liquid always tries to acquire minimum surface area. So this liquid pulls the frame, tries to pull the frame from all sides to shrink itself so that it can acquire minimum surface area. But if you watch little carefully, as I told you earlier, this side, this side, and this side is fixed. As the sides are fixed, these forces of surface tension cannot pull that frame towards it. So their force is useless. They're not going to do anything. But look at this force. Look at this force. As this frame, the fourth side is movable. That is successful in moving the film, in moving that slidable frame, slidable fourth side a little into it. By how much it pulls, we can calculate based on the definition of a surface tension. We know surface tension is defined as force acting per unit length. In the place of the length, we have to consider a part of the length that is in contact with the free surface of the liquid. This length, L if we call, its inner surface as well as the outer surface, both are connected to the liquid. Hence, in the place of the length, I have to write 2L. 2L in this case because the free length that is in contact with the surface of the liquid is both sides of that movable wire. That is 2L. That implies with the force F acting in this direction, how much is that? T into 2L acts in this way. As I told you, this way. This is the force. Because of that force, that movable frame moves a little inside. Let that is moved by a distance something like a small value dx. Only for the sake of a diagram, I am showing it like a bigger value, bigger size dx, but that's a very small value actually because surface tension force is a mild, minute force. So with that certain force, it has gone inside. So when it has gone inside, if you want to, why it has gone inside? Because of the surface tension. So the surface some work. How much work it has done, I can calculate. So work done by liquid surface in moving the displacement dx can be calculated as work done is force into displacement. Force is F here, displacement is dx. But we have already calculated the value of the force basing on the definition of surface tension. How much that force is? T into 2L. And of course, this dx I have written. So this is T. 2L is the free length of the liquid surface. Dx is the change in its breadth. This is its value. This is its value. So length into breadth, if it is, I could have been writing an area, but this is length into change in the breadth. Therefore, it's not going to be complete area. It's only a change in area where delta A is, what do you mean by delta A here? Delta A is change in area. So we need to do a work, or else the liquid has done a work, liquid surface has done a work, T into delta A, in displacing the liquid surface towards inside so that it has required a minimum surface area. Say if you want to restore back, we shall apply the same energy or we shall do the same kind of the work. So this is the amount of the work done by the liquid. After doing this work is being stored on the surface of the liquid, and that energy is called something like obviously surface energy. So you can say surface energy E is equal to T into delta A, or work done equal to T into delta A. So we can define surface tension in this way also. This implies what we can say, T equal to energy or else work done per unit change in the surface area. So this is another way of defining surface tension. Work done in producing a unit change in the surface area of a liquid can also be called as a surface tension, like a force acting per unit length on tangentially on a imaginary line drawn on the surface of the liquid. This is another way of defining surface tension. We can get another formula. Work done is something like energy. Energy is measured in joule by change in area is meter square. So the another unit is joule per meter square. Though it looks like a different unit, that's not actually different. It's the same being expressed in another way. Just to check it, you can write a dimensional formula. I will write a dimensional formula here and show you, right? What is the formula I have got? Work done per unit change in the area. Work done is force into displacement by change in area. Force is mass into acceleration. Mass has a dimension of m. Acceleration is velocity by time. That has a dimension of Lt power minus 2. Displacement is again L. Area is L square. So this L square and this L square will get cancelled. So dimensions is m power 1, L power 0, T power minus 2 is the same as the dimension that we have got in the previous case. So you can express surface tension either this way or this way. This is another way of expressing surface tension. Work done per producing a unit change in the surface area of a liquid can also be called as a surface tension. So to remind you back, there are two ways of saying surface tension. Either you can write force acting per unit length, or you can write work done in producing a unit change in the surface area. So which one you use simply depends on what is your requirement in a given situation. Basing on that, we can decide. Actually, both are same, they are different forms of a same thing. That's it. Thank you for watching. I will further continue this discussion and try applying it in some cases and solve some problems in our coming videos. That's it.